Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. We are still working with polynomials, and today we are going to look at how do we factor polynomials. Factoring, we already learned factoring of quadratics. Now, what if it's more than a quadratic, or if I have more than three terms, more than a trinomial? It's a general polynomial. What do we do in cases like that? I have a worksheet here that has like 23 or 24 questions. Again, because there are too many, maybe I'll do even numbers. We'll see. So if we start here, say with number 2, let me bring a sheet of paper so we can show the answers or the solutions on it. It's not going to be crammed. Okay, so let's keep this here and start with that one. So should we do odds or evens? I can't remember what we did last time. Okay, I said even, I think. So let's say when factored completely, x cubed plus 3x squared minus 4x minus 12 equals what? So usually when you get something like that, of course they work the numbers easy for you in the region so you don't get like, crazy stuff. What can you do? Notice that it's a polynomial. There is no like terms or anything. You either take the first two, combine them together, and the second two, combine them together, or you take the first and the third, and the second and the fourth. Both will give you the same answer. So for number 2, I will do it both ways so you can see it, but then after that, we'll pick just any method. So if I combine the first two in one pair of parentheses, notice I have a negative sign. So when I say negative, I'm going to switch the sign of these two things. So it would be 4x plus 12. Okay? If I pick the first and the third, the second and the fourth, let's do it with a different color. I will get x cubed minus 4x plus 3x squared minus 12. Here, what I can factor from the first pair of parentheses is the x squared, which leaves me with x plus 3, right? Dividing by x squared, you get x. Dividing by x squared, you get 3. Here, you can factor out the 4. Dividing 4x by 4, you get x. Dividing 12 by 4, you get positive 3. See? If you come here, I can only factor x from the first one, and that leaves me with x squared minus 4. And then I can factor only 3, which leaves me with x squared minus 4. So if I continue here, I see x plus 3 on the first term, x plus 3 in the second term, so I can factor this out to be the exact opposite of what I will do there. What remains from the first term, if I divide by x plus 3, is x squared. What remains from the second when I divide by x plus 3 is negative 4. Here, I see x squared minus 4 and x squared minus 4, which can be factored out. And when I divide this term by that, I'm left with x. When I divide this by that, I'm left with positive 3. Notice it's the same exact answer. The only difference is that the commutative law works here. Don't stop, because when you look at the second term or the first term here, you see it's a difference of 2 squares. This is x squared minus 2 squared. So I can factor it as x minus 2 times x plus 2. Same thing here. The first one is a difference of 2 squared, x minus 2 times x plus 2 multiplied by x plus 3. So it really doesn't matter if you pick the first two and the second two, or the first and third, second and fourth. We have x plus 3, x minus 2, so it's 2. The third is correct, but it's not factored completely. Notice here they tell you to factor it completely, okay? Or else this one would be also correct, but here you can factor the x. They stopped here, right? Or here. X squared minus 4 times x plus 3. Okay, so now we know basically how to do it. Most of them will have a difference of squares. What if it's a difference of cube or something higher? We'll learn that in the next session. Okay, now let's go to number 4. Also, when factored completely, the expression 3x cubed minus 5x squared minus 48x plus 80 is equivalent to. Again, I don't care which one you pick. I'm going to pick the first two and the last two and put them between parentheses. 3x cubed minus 5x squared. Notice again, I have a negative sign, so I change the signs. This first term was negative, I make it positive. The second one was positive, I make it negative. Here I see that the 3 and the 5 don't have anything in common, but x cubed and x squared, I can factor out x squared. That leaves me when I divide with 3x minus 5 minus 48 and 80. 48 is 16 times 3, and 80 is 16 times 5, so I can factor out 16. If you don't know how to do it, again, remember we can find the factors of 48. 48 is an even number, so it's divisible by 2, and that leaves you 24. 24 times 2. 24 is even, so it's 2 times 12. 12 is even, so it's 2 times 6. 6 is even, so it's 2 times 3. The 80, even. So divided by 2 would leave me with 40. Divided by 2 will give me 20. Divided by 2 will give me 10. Divided by 2 will give me 5. So now when you see what can be factored, I have a 2, a 2, a 2, and a 2. So I have 4 2's. 4 2's, meaning 2 times 2 times 2 times 2, which is 16. So that's what you factor out. 48x, the 48 over 16 is 3. So I get 3x minus 80 over 16 is 5. So I get minus 5. Again, I have 3x minus 5, 3x minus 5. So I factor this out, and that leaves me here with x squared and here with negative 16. For the second time, it's a difference of 2 squares. So I'll factor it again as x minus 4 times x plus 4, and that's factored completely. So 3x, 3x minus 5, it's 3, right? Yeah, it is 3. Okay, so that's the first two. Now when we go to number 3, here they don't give you choices. You have to just factor it completely. Not agree. Okay, number 6. It says x cubed. I don't think we need to keep going. Well, after that, there is no cube, but okay, let's do this one. This time we factor the first two. This time I'm gonna factor first and third, second and fourth. It really doesn't matter, as I told you. So I get x cubed minus 25x, and then there is a negative, so I'm gonna switch the sign of negative 6x squared. It becomes positive, and the positive 150 becomes negative 150. Here I can only factor x, which leaves me with x squared minus 25. Notice it, difference of 2 squares. Here I can take the 6 out. That will give me x squared, of course, minus 25. Next step, I factor out the x squared minus 25, and that leaves me with x minus 6. And lastly, I factor the x squared minus 25 as x minus 5 times x plus 5, x minus 6. Okay. By the way, sometimes you need to check your answer. Uh, how do I check my answer? I know, for example, that what makes this product equal 0 is x equals 5 or negative 5 or 6. You can pick any one of them. Let's say we pick x equals 5. So, of course, this product is 0. Will I get 0 if I substitute x equals 5? If I substitute x equals 5, I get 125, which is 5 times 5 times 5, minus 6 times 25 is 150, minus 25 times 25 is negative 125, plus 150, and these add up to 0. You see 150 and 150, 125 and negative 125. So that's a quick way to check. I could have done it here and there, pick x equals 2 and see what you get. You should get 0 on both. But again, if you are confident you did it correctly, but if you have time, it's always good to check your answer. Let's move to number 8. Number 8 is slightly different here. We don't have a cube form, but I have 2x minus xy plus 2y minus y squared. Again, I can pick the first two and the second two, or the first and third, second and fourth. Of course, they can be shuffled. So that's not like you always do that. But how do you think about it? Here, if I factor the x, there is a constant and a y. And here, if I factor the y, there is a constant and a y. So I can pick these two together and those two together very easily. 2x minus xy plus, because it's plus, I'm not going to change the signs, 2y minus y squared. I can factor x here, and that leaves me with 2 minus y, and I can factor y here, which leaves me with 2 minus y. Now I take 2 minus y as a common factor. That leaves me here with x and here with y, and that's the answer. Okay, so that is number 8. Let's do number 10 here. A cubed minus AB plus A squared minus B. Same thing. I'm going to take the first two, or the first, maybe here, I'm going to take the first and third, second and fourth. So I get A cubed plus A squared minus, because I took a minus, I will change the sign of these two and both would be positive. I can factor A squared here and it leaves me with A plus 1. I can factor B here and it leaves me with A plus 1. Finally, I factored the A plus 1. That leaves me with A squared here minus B there. And that's it. I cannot factor it anymore. Yes, that's a square, but it's not a difference of two squares. It's a square and a linear. So I cannot do anything unless I use roots. And that's not what we are doing here. Number 12 is on the next page. I think all of them are similar. Let me see if there is something that is more interesting, because all the squares and constants, and this one may be interesting. It has a to the 6. Maybe the last one. So we can do these two, 19 and 23. 19 says a to the 6 minus a to the 4th minus a squared plus 1. And again, I can do the same thing. If I take these two, the difference in power is 2. And I take these two, the difference in power is 2. So it works. Or I take first and third, the difference in power is 4. Second and fourth, the difference in power is 4, so also it works. So I can say a to the 6 minus a to the 4th, and then there is a negative, so that would become a square minus 1. Be careful. I can factor a to the 4th. That leaves me with a square minus 1 minus a square minus 1. This one is the tricky one. I'm going to factor the a square minus 1. And that leaves you with a to the 4 minus 1. This is a difference of two squares, and that's also a difference of two squares. So don't do this and stop. This can be written as a minus a and a minus 1 and a plus 1. Be careful with this one. When you factor it, you get a square minus 1 times a square plus 1. Guess what? This one will give me those again. It will give me a minus 1 times a minus 1, so that would be a minus 1 square times a plus 1, and there is another a plus 1. So I will end up having a minus 1 square times a plus 1 square times, so I factor this into those two, and that leaves me with a square plus 1. Okay? Be careful that I had to factor this twice. It's a difference of two squares, and this is a difference of two squares. And finally, we'll do number 23, the last one. They tell you to factor completely 3bc minus 4ad plus 6ac minus 2bd. I see that the 6 is the double of 3 and the 4 is the double of 2, so I can factor these two together and those two together. Or the first and the third, the ratio of the coefficient is 3 to 2, and the ratio of these coefficient is also 3 to 2. Of course, one is positive and one is negative. So I really can take the first and fourth, second and third, or first and third, second and fourth. So we don't just combine any two terms. You have to see that there is the same relationship. So if I pick first and third, I get 3bc plus 6ac minus, and then I'm going to pick these two with a negative sign, so I change that into positive and that into positive, 4ad plus 2bd. Here I can factor 3 from the numbers and c as the same coefficient, same variable. So that leaves me with b plus twice a. Do you see that? When I divide this by 3c, 3 and c cancel, and you get b. Here, 6 over 3 is 2. A stays, c cancels. Minus 4 and 2, it's only 2. I can factor 2. AD and BD, I can factor D. So that leaves me with 4 over 2 is 2. A stays and the D's cancel. Plus 2 over 2 is 1. B stays and the D cancel. Now I have 2a plus b and 2a plus b. The order doesn't matter. Your commutative law tells you that I can factor 2a plus b. That leaves me with 3c in the first minus 2d in the second, and I cannot factor anymore. We stop here, and that's the end of factoring. So this type of factoring that involves difference of two squares is very common. You will encounter it a lot. The last one didn't have difference of squares, but it had, you have to know which two you combine together so that you get the same common factor. So I think that's good for today. In fact, in a little while, I will make another video for what if I have cubes in power of 4 or something, difference of two cubes instead of difference of two squares, or sum of two cubes, and we see how we combine those and how we factor those. So at least this one would be about one type of factoring, and the other one would be slightly different. As usual, if you have any comments, please let me know. Otherwise, I wish you all the best. Hope to see you tomorrow.